This is what our Milky Way galaxy looks like. And this, and this, and this. Let me explain what I mean. So this is a CD. It's a bit of an ancient artifact by today's standards, but it stands for compact disc. Now, they're also a pretty good representation of another type of CD, that is the cosmic disc, what we think of as spiral galaxies. Now, this is a massive oversimplification, but galaxies tend to come in two forms. Either they are disc-shaped, sort of like this, or they are elliptical, meaning that they're kind of egg-shaped. Now, our Milky Way is a spiral galaxy, which is an example of the former. That is, it's a disc-shaped galaxy. Spiral galaxies are the archetypal cosmic disk. They are the CDs of space. But first, before we get to that, let's talk about these CDs, the CDs of Earth, because they're actually quite miraculous. Now, I know I'm just another Gen Z who's discovered physical media, but listen, I was born in 2002. CDs are of my era, so I'm qualified. Plus, CDs are awesome, so I think that they need to be discussed more often. So CDs are actually extraordinary. They exist at a very unique point in human history between analog and digital media. CDs are both. You have this physical thing that goes into another physical thing and then plays real audio, but the actual information itself is digital. It's binary. So essentially, if you were to look at a CD under a microscope, you would see that it's covered in a bunch of these little grooves. Those of us on the inside call these pits and lands. But essentially, all you need to know is that these little grooves are covering the shiny side of a CD. The track that these pits and lands live on is incredibly thin. It's only about 500 nanometers thick. That's about 200 times thinner than a piece of paper. Inside the CD player, as the CD spins, there's a little laser that shoots at those pits and lands, and depending on how that laser bounces back onto the sensor, it will read back that information as binary. So how much binary can a CD actually hold? Well, the digital answer is about 700 megabytes. That's about 80 minutes of audio. But the analog answer to that question is a lot more interesting. The readable track makes a spiral on the back of the disc, starting on the inside and making its way outward. Now, if the disc is about 120 millimeters across and the track is 500 nanometers thick, that means that there is a lot of track on the back of the CD. In fact, if you were to take that spiral track and unwind it and straighten it out into a completely straight line, that would equate to 5 kilometers, or a little over 3 miles of track. 5 kilometers of those pits and lands. That's quite a bit of binary. This means that when you put the CD into the CD player, it's reading about 60 meters of track for every minute of audio that you're listening to. That equates to about 1 meter of track per second of audio. Now, I think there's something really cool about that. There's no physical representation of the music that we listen to on Spotify, for example. It's just not the same with things that are online. Now, regarding the actual physicality of the CD itself, I've already mentioned that it's 120 millimeters across. It's actually 1.2 millimeters thick, meaning that it's exactly 100 times wider than it is thick. You could stack 100 CDs across the diameter of a single CD. Coincidentally, this is actually the same as our Milky Way galaxy. Our Milky Way galaxy is 100,000 light years across and 1,000 light years thick. At least that's the dimensions of the thinnest disk part of our galaxy. This means that this disk part of our galaxy has the the same exact proportions as a CD. So when you actually stop and hold a CD in your hand, you're holding something that's remarkably thin, but those proportions are quite similar to the thinnest part of our galaxy. Now, in reality, our galaxy isn't quite like that. It's actually slightly warped, like if you were to put a vinyl record in the oven or something, and it has a bulge in the center where the densest cluster of stars is. But regarding the actual disk part of our galaxy, it is quite thin. So while the proportions between a CD and our Milky Way galaxy are somewhat similar, the dimensions are obviously not the same. The CD is 120 millimeters across and 1.2 millimeters thick. We would have to scale that up 10 to the 22 times in order to get it to be the size of the Milky Way galaxy. That's a 1 with 22 zeros behind it. Let's pretend for a moment that this CD actually is our Milky Way galaxy. Around the center hole here, that's where you would find Sagittarius A star. That's the supermassive black hole that lives at the center of our galaxy. It's about 4 million times the mass of our sun. Around the main part of the CD where the actual data is written, this is where you would find the spiral arms of our galaxy. This, just like on a CD, is where the magic happens. It's where starburst regions tend to be. This is areas of active star formation. Not so coincidentally, in this magic area of the disk is where you would find us. It's where you would find our sun's soul, here, hidden amongst hundreds of billions of other stars. Okay, so this CD in my hands obviously isn't the Milky Way galaxy. The Milky Way galaxy is our home. It's 100,000 light years across, 1,000 light years thick, and contains hundreds of billions of stars. However, this little disk is a pretty remarkable feat of human ingenuity. It doesn't contain hundreds of billions of stars, but it does contain 6 billion pits and lands. Up to 6 billion of those little divots, those little engravings that contain the binary of music. Music that we were genius enough to come up with. On this planet, Earth, intelligent life evolved to be smart enough to not only create music, but create a clever way of reproducing that music and sharing it with others. Life intelligent enough to make creative music and share it by laser engraving billions of grooves into a polycarbonate disc. Billions of grooves that are then read back by a laser. Like, it's amazing. The next time you hold a CD, think about it. Consider that it shares approximately the same proportions as the Milky Way galaxy, the cosmic neighborhood that we live in. Think about how thin it is. Consider those proportions as you slide it into the CD player and listen. Let's do it. Okay, I think that went really well.